Regardez mon papa. Il arrange le chargeur USB. Regardez le petit chargeur USB qu'il a déjà arrangé. C'est joli, hein? Ok. C'est bon?
Oui.
Regardez ici. Le frigo water plus chinois.
C'est chinois, oui. Tout est chinois.
Chinois.
Okay, so here we have our four USB modules, all with wires soldered onto them, ready to go, tested. They work. These are the Quick Charge 3.0, so they will do 5 volts, 9 volts, or 12 volts auto detecting. We have the standard USB and the USB Type-C, all ready to go with the portable solar system. Okay, so we have a trial run here. Here are our two 12-volt batteries in series for 24 volts, about 500 watt hours, so half a kilowatt hour. Here's our MPPT solar charge controller. You can see we're fully charged right now, 0 amps. We're at 28.9 volts, which is my cutoff voltage for the PV. And right now we have 0 amps, 0 watts. Here we have our two Quick Charge 3.0 USB chargers, a USB-C and normal USB are connected and working. And here we have a power inverter that I'm somewhat less than impressed with. Here's why. I'm going to switch it on. Now, keep in mind there is no load on this power inverter. There's nothing plugged in and illuminated, working on it. So I'm going to switch it on. Now it's switched on. Notice here we're consuming a half an amp of current and 15.6 watts of power with the inverter switched on, but nothing plugged in. Or switched on, no load. So that's unfortunate that it's consuming quite a bit of power even when it's not doing anything. Now we have here wall clippers as an example. This will probably consume around 100 watts. So we're going to switch it on and just see what it does. And you can see here with the wall clippers turned on, as I estimated, we're around 100 watts of power consumption. So 4 amps, just under 4 amps at 28 volts. The panel is currently generating. We have a lot of sunlight right now, so it's currently generating more than enough to keep up. You can see it's just on a trickle charge here. It's just coming on every few seconds to top off the battery. So even with a small portable panel, we're generating more than enough for this appliance. This system should put out around 200 watts continuous, but the inverter is capable of 500 watts continuous. So conceivably, it could run a small refrigerator or other small appliance continuously, even through the night, because we have a half a kilowatt hour of battery storage after the sun goes down. So now we just have to get all of this stuff in a nice organized plastic case with a carrying handle, all arranged nicely and professionally, and then we will be good to go. Now, some of you might be wondering what those other things were that I didn't mention here. So here we have two, these are step-down voltage converters. They're going to convert and regulate our voltage to 19 volts, such as for laptop computers and other similar appliances, and 12 volts for anything that's designed to run on automotive power. And here, as you know, with anything electric, you must have circuit protection. So these are our fuses, a little fuse block here. We have our 24 well, it's really 28 volts in, and an individual fuse for each circuit. Here is the on the left is 30 amps for the power inverter, and we have 20 amps for the DC to DC converters. Here we will add, for example, 15 for the USB ports, and then we'll add a fourth one. Not absolutely sure what we'll do with that yet. It'll probably be a straight 24 volts for 24 volt appliances.